Hello, here we are again with another A-level maths video. This is on chapter 3 of the Pure Mathematics Year 1 textbook. We're looking at section 3.2, still looking at simultaneous equations, but this time we're including quadratic functions as part of that. Now, in the previous video, the previous section of the chapter, we looked at simultaneous equations and we recognized there were two common ways that people use to solve them. One was solving by elimination and one was solving by substitution. And what I'd like you to do now is consider the question on the screen. Try and solve those simultaneous equations by elimination. What goes wrong? Okay, so what do you think about this? If we're going to try an elimination method, what we've got to try and do is try and make either the x terms match up or the y terms match up in both equations, so that we can either add or subtract one equation from the other to eliminate. So here, because we've got an x squared term here and a y squared term here, we might be thinking about squaring both sides of the equation 1 here in order to try and make these things match up. So let's do that and see what happens. So if I take equation 1, square both sides, I'm going to end up with x plus y all squared on this side and 2 squared on the right hand side. Expanding all that out, we end up with x squared plus 2xy plus y squared equals 4. And you might think to yourself, hey, that's good because we've got an x squared term here and an x squared term here, so we could maybe subtract this equation from this equation, and that way we'll eliminate our x squared terms. But hold on a second. Can you see that we've got this extra term appearing which still has an x in it? We've got this extra 2xy term, which means that actually we haven't eliminated our x after all. And that's what goes wrong. So what does that mean for us? Well, what it means is whenever we have simultaneous equations where one of the equations is a quadratic or has anything quadratic in it, we can't use an elimination method. We must use a substitution method. Let me show you an example of the kind of thing I'm talking about here. So we have simultaneous equations on the screen there. You can see the first of those equations involves quadratic functions there, the x squared and the y squared. We've been asked to first of all show that 5x squared minus 24x minus 5 equals 0. So in other words, we need to eliminate the y's by using a substitution method and then use that to solve the simultaneous equations. So here's how it's going to work. Here's my two equations here. I need to try and eliminate the y. So I'm going to take my second equation and I'm going to try and make y the subject of that equation. So if I add y to both sides and subtract 8 from both sides, we end up with y equals 3x minus 8. Now, do you remember how this works with the substitution method? What I'm now going to do, I'm now going to go to the other equation, which was the first one, and rewrite it, but wherever I see y in the equation, I'm instead going to write 3x minus 8. Here we go. X squared plus y squared, which is of course 3x minus 8 squared, that equals 74. Oops, 74. There we go. All right, now I'm just going to expand this out, and hopefully it's going to lead us to the equation we can see on the screen here. I'll quickly whiz through the algebra here. So expanding this out, 3x minus 8 times another 3x minus 8. We end up with 9x squared minus 48x plus 64. That all equals 74. And then collecting terms together, we are going to end up with x squared plus 9x squared here becomes 10x squared. We've got a minus 48x here. Subtract 74 from both sides, we end up with minus 10 equals 0. And I can see, comparing this with what I want it to see on the screen, if we just divide both sides of this equation by 2 now, we end up with the equation we've got on the screen there. So we've done the first part of the question. Cool, right, okay, so let's now continue and solve the simultaneous equations. What we've done is we've eliminated by substitution. We've sort of substituted to eliminate the y terms. We've got ourselves a quadratic equation in x. I can solve quadratic equations. Hopefully you're getting pretty good at these by now as well. I'm going to factorize this. So we end up with, I think, 5x plus 1 and x minus 5 as the factors, which leads us to solutions for x of negative 1 over 5. And this one here, x equals 5. Now we're not finished yet because of course with simultaneous equations we need to find the y values as well. Let me just move this back up. So we found that y equals 3x minus 8 here. So in order to find the y values which relates to each of these x values, we're just going to substitute back into there and get our answer. X equals negative 1 over 5. Then y is going to equal 3 lots of negative 1 over 5 minus 8. And that all becomes, I think, minus 43 over 5. And then if x equals 5, which was our other value for x over here, then y is going to equal 3 lots of 5 minus 8, which I think is just 7. So that means actually, because we've got something quadratic going on here, we've actually got two solutions, or two pairs of values, each of which is a solution. When x equals minus 1 over 5, then y was minus 43 over 5. I'll write that down here. X equals minus 1 over 5 and y equals minus 43 over 5. That's one of our solutions. But we've got another solution here, which is when x equals 5, y equals 7. So those are the two solutions for this simultaneous equations. Okay, did you follow what was going on there? If not, obviously go back, rewind the video, have another watch, pause it if you need to stop and think. But when you're ready, there's a question on the screen for you to have a go at. So first of all, you'll notice that we have to eliminate the x's first of all to get the equation on the screen, which involves only y. So do that bit first by a substitution, and then use that to solve the simultaneous equations. Okay, let's quickly run through the answer of this one then. This is the kind of thing you should have done. Now, we need to take our linear equation here. And because we are eliminating the x's this time, I want to rearrange this to make x the subject. So if I take that second equation, equation 2 here, look, and I just subtract y from both sides, we end up with x in terms of y. X equals 3 minus y is what you should have got there. Then we're going to substitute into the other equation. In this case, it's the first equation. So wherever we see x, we're instead going to write 3 minus y. X squared is 3 minus y, all being squared, plus y squared here equals 5. So there is our equation, which is just in terms of y. And now we just need to do a bit of algebra on this to show that it turns into the equation you can see on the screen here. Let me just quickly go through the steps here. So 3 minus y all squared becomes 9 minus 6y plus y squared. Got another plus y squared here equals 5. Now we'll just collect the terms together. Y squared plus y squared becomes 2y squared minus 6y. Subtract 5 from both sides, so we end up with a plus 4 equals 0 here. And if you just divide both sides of this equation now by 2, we end up with what we need right there. Okay, so far so good. Now let's see if we can solve this quadratic equation here. Again, this one factorizes nicely. So let's do it by factorizing. We end up with y minus 2 times y minus 1, which leads us to values of y equals 2 or y equals 1 are the two possible values of y we could get. Okay, we're not done yet though, because we need to find the corresponding values of x. Let's just move the paper back up so we can see here x, of course, equaled 3 minus y. That came from rearranging that second equation. So if I now just take my y values that I found, y equals 2, then x equals 3 minus 2 equals 1. And if y equals 1, which was our other possibility down here, then x equals 3 minus 1, which is, of course, 2. So what that means is the solutions we ended up with here, we either had x equals 1 and y equals 2, or x equals 2 and y equals 1. And those are our two solutions here, one solution there and one solution there. Okay, how are you feeling about this topic? I'm going to give you one last question to do in this video. You're on your own here, I'm not leading you through it. You need to work out for yourself what you might want to eliminate, what you might want to make the subject, and what you're going to substitute into the other equation. Okay, pause the video, give it a go, and then a restart once you think you've done. Let's have a look at this one together then. So Hopefully you spotted that we're going to need to rearrange the linear equation to substitute that into the other. I think that's the easiest way of doing it. And you could actually make either y or x the subject here. I chose to do it by making y the subject here, because I could just add x to both sides. So taking that first equation and rearranging it, I chose to make y the subject, which is y equals 1 plus x here. Now, if you chose to make x the subject, your work is going to be slightly different from what I'm about to do, but you should have ended up with the same answers at the end. All right, so let's see if I can continue from here. Wherever I see y, I'm now just going to write 1 plus x in this other equation. And take equation number 2. 2x squared minus 11 lots of, and instead of y, I'm going to write 1 plus x equals negative 16. And now we're just going to tidy this up. 2x squared minus 11 times 1 is, of course, minus 11. Minus 11 times the x is minus 11x. I'm going to add 16 to both sides. And then I'm nearly there with this, because I can take the negative 11 here, add it to the 16 here, and I think I get plus 5 equals 0 like that. Okay, so hopefully we're all agreeing so far. Let's just move the paper up here. So again, this one factorizes. So nothing complicated going on in terms of the solution. I think we end up with 2x minus 1, and then x minus 5 are the factors, which leads us to values of x of 1 over 2 and 5. Okay. Still need to find our y values, of course. Let's move the paper back up. So remember that y equaled 1 plus x here. So let's just substitute in each of our x values one at a time. If x equals 1 over 2, then of course I think 1 plus 1 over 2 is going to be 3 over 2. So there's one of our solutions there. X equals a half, y equals 3 over 2. And of course the other solution is if x equals 5, well then y is going to equal 1 plus 5, which is of course 6. So those are the two solutions that you should have ended up with. Okay then, so simultaneous equations which involve quadratic functions there. Get a bit more practice by having a look at the questions in exercise 3b of the textbook. Page 41 and 42 is where you'll find those. Next video, we're going to be looking at graphical ways of looking at simultaneous equations. But for now, I'll see you. That's it for now, and I'll see you next time.